So the pressure, there are several terms. Bring this up a little bit so we can see it. Okay, absolute pressure is measured with respect to zero pressure. Gauge pressure is what's going to be used in the exam, unless they go ahead and just say what would be the absolute pressure. It would be the gauge pressure plus atmospheric pressure. Atmospheric pressure, of course, is 14.7 psi at sea level, and that's, of course, in your handbook. You can find it there in your standards. All right, so mostly you'll be dealing with gauge pressure. When we take a look at this figure, the gauge pressure is going to be 0 of the top or an open reservoir. Okay, so most problems you'll be dealing with gauge pressure. You don't have to worry about applying atmospheric pressure when it's open to the atmosphere. Okay, so pressure, of course, we're English US units, pounds per square inch, or PSI, right? And SI units were in kilopascals, etc. So these fluid heights equivalents, they're important. And here's an important conversion right here. 2.31 feet of water is equal to 1 pound per square inch. And what does that mean? Okay, as a reminder, so if you were to inject 1 pound per square inch of pressure in this tube of water, it would raise the water up 2.31 feet. So we can convert pressure in PSI to feet of water and back and forth using that important 2.31 feet of water per PSI. And we see some other various conversion factors also. So as we continue down this page, we see the next fluid property is density and unit weight. At the top of page 3, you can see that I've listed out the properties of water. That is on page 30 also of your PE handbook. All right, so of course density is the mass per unit volume. Unit or specific weight is also going to be in the units of pounds per cubic feet. That's the weight per unit volume. Okay, they're numerically equal. And so the density of water and specific weight of water are approximately 62.4 pounds per cubic feet at room temperature. Specific gravity is the ratio of a mass or weight of a certain sample to its mass or weight of an equal volume of water. So the denominator is water, and then the numerator is going to be whatever your fluid is now. Specific gravity, here it is, density of the liquid divided by the density of water, right? Specific gravity. So, for instance, the density of an oil or hydrocarbon is less than the density of water, so it floats on top of the water, right? Specific gravity would be less than 1. Acids, caustics, and other chemicals and some sludges are going to have a density greater than water, and so they're going to have a specific gravity of greater than 1.0. Viscosity is a measure of a fluid's resistance to flow when acted upon by an external force. There are 2 viscosity terms. One is referred to as the absolute dynamic viscosity, which we're going to see in the next table. So we turn the page. And the other is going to be what's called the kinematic viscosity. And kinematic viscosity is used in the Reynolds number. It isn't like an italicized V. It's Greek letter nu. It's in units of feet squared per second. It is the absolute viscosity divided by the mass density. And since the viscosity and density are so important to how the fluid behaves, those who have prepared equations before us have gone ahead and just made this term kinematic viscosity using both of those terms, absolute viscosity and mass density.